Hey, I'm Loujack, and I'm going to tell you all about neurons and how they communicate. So, neurons communicate by firing sodium ions through an axon, which is this portion right here. I don't know if you can see it. Let me zoom in a little bit. There we go. And anyway, so they are pumped through this axon, and it triggers a process called depolarization, and it's when, you see, initially this whole portion here, this axon, is filled with negatively charged chlorine ions, and the myelin sheath contains the positive, so negative inside and positive outside. But when the sodium ions begin to pump, the charge is disrupted, and when this happens, potassium ions, the symbol for that is K, leak out this inner tube. And the exchange of these new positive ions for the old, it kind of creates this domino effect, like whoosh, 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 whoosh. And as each sheath opens up, so does the next one. So they'll pass through here, and once the sodium ions have passed through, everything goes back to normal. And that's a different thing I'll get to later. It's called refraction. But this process of this domino effect of positive ions is called action potential. And in order to trigger this reaction, the sending neuron has to receive some kind of signal. It can either be an excitatory signal or an inhibitory signal. And this signal, the difference between these signals, in other words, one charge minus the other, it must reach a minimum sort of charge, which for neurons is negative 55 millivolts, and that is something called the threshold, that minimum charge. And once it gets up to that point, the reaction happens. So whatever signals they receive, it'll only happen if it reaches that threshold. And that's how the chain reaction starts in the axon. And once, like I said, once it's passed through, refraction happens, and it just kind of flows back in or out, and it primes itself for the next wave of sodium ions. And these neurons, they don't just fire once. They can fire anywhere between 100 and 1,000 times per second, so you usually need this really quick sort of refraction for the next chain of sodium ions. And at the other end of this axon are these things called synapses. I don't know if you can see them. Let me see if I can zoom in a little more. All right. And these synapses right here, these synapses look like this up close. And this little weird Erlenmeyer flask looking thing, that is the axon terminal. And that's why these things look like kind of little buttons. And it's this end of the axon where these vesicles are triggered by this reaction up here with the axon. So once the action potential reaches here, see, I kind of labeled it in here, these vesicles will start to release these neurotransmitters. And what these neurotransmitters do is they act kind of like enzymes. And if you know anything about enzymes, they're like a lock and a key. And these are like the locks. No, not the locks. These are like the keys to the locks. And the locks are like the receptor sites down here. And the receptor sites kind of do as their name suggests. They accept these neurotransmitters that cross this little gap right here. And these pump out through here. And when they accept the neurotransmitters, these keys, these special transmitters, they open or close special holes for the ions that were passed through this axon, for the ions to go through. So holes can be opened or closed when these things react. And the ions, whether or not they pass through or not, will determine what the receiving neuron interprets as an excitatory or inhibitory signal. So it's all just a lot of chain reactions here. And it almost depends on what one neuron gets sent from the others. It really is an amazing thing. And one more thing is that once this process is over, and not all, but the receptor sites are filled with whatever neurotransmitter is being secreted. The leftovers in this little gap right here, they get sucked back in a process called reuptake. And it's where excess neurotransmitters are absorbed back in to the synapse, and they're reused for the next time they receive this special signal. So that's it for now, and I hope you learned something in this video. Thank you.